Well, let's try another problem. Here we have a compound that's analyzed and found to be 40% carbon, 6.67% hydrogen, and the rest oxygen. The molar mass of the compound is 180 grams per mole. Determine the empirical and molecular formulas for the compound. So go ahead and pause the podcast, and I'll see you back here in a couple minutes. Welcome back. Let's talk about the solution. Our first step was to take percent to mass. So you see that here. And one of the things that was not given to you in the problem was the specific percentage of oxygen. But when you've seen a problem where it says the rest is this element, then you just take the other percentages of elements, subtract them from 100, and that will give you the percent of that other element. So it's 53.3% oxygen. We change that to 53.3 grams, 40 grams of carbon, and 6.7 grams of hydrogen. Our next step was to take those masses and convert to moles, and you can see here that we got 3.33 moles of carbon, 6.67 moles of hydrogen, and 3.33 moles of oxygen. We then divide by the smallest mole quantity to get the mole ratio, and you can see here two of our mole quantities were equally small, which makes this very easy to do. So our mole ratios are 1 mole of carbon for every 2 moles of hydrogen and every 1 mole of oxygen. Our empirical formula is CH2O, and our empirical formula mass then is 30 grams per mole. Now, the last step of this would be to multiply to a whole, but since our mole ratios are whole numbers, there's no need to do this. So we do have an empirical formula of CH2O, and we just have to compare the empirical formula mass to the molar mass to see what the molecular formula is. So here's our ratio of the molar mass to the empirical formula mass. 180 grams per mole divided by 30 grams per mole gives us 6. We take 6 times the subscripts in the empirical formula, and we get the molecular formula of C6H12O6. If when you do this mass ratio of the molar mass over the empirical formula mass, if you get a number that is not a whole number, like you get 4.5 or 3.33, you probably need to go back and rework the problem because there's an error somewhere. This mass ratio should always be a whole number. Let's try one more problem. Here we have a 2-gram sample of the main hydrocarbon contained in gasoline undergoes combustion analysis and is found to contain 1.684 grams of carbon and 0.316 grams of hydrogen. We want to find the empirical and molecular formulas for the compound, given that its molecular mass is 114 atomic mass units. You want to go ahead and pause the podcast and work this through, and I'll see you back soon. Welcome back. Let's see how you did. First step, of course, was to take our percent mass, but here it's not necessary because you're given these quantities in mass right up front, number of grams. So we can go right to the step of mass to mole. But it is always good to follow a system. Problem-solving systems help you to eliminate unnecessary errors or careless errors. So if you can think of this percent to mass, mass to mole, divide by small, multiply to a whole as an algorithm to check yourself as you go along, it can be very helpful to you. So we're going to skip the percent to mass step and go right to mass to moles. And you can see in the calculations we got 0.1403 moles of carbon and 0.316 moles of hydrogen. Once we've got the moles, we're going to find our mole ratio by dividing by the smallest. When we do that, you can see that we get a mole ratio of 1 mole of carbon to every 2.25 moles of hydrogen. So if we were to write an empirical formula for this, it would be CH 2.25, and that should send off alarm bells in you that you cannot have a quarter of a hydrogen atom in a molecule. So we'll have to go to the next step, which is multiply to a whole. In order to get 2.25 to a whole number, we're going to multiply by 4. So we take 4 times the subscripts in the mole ratios in the provisional empirical formula to get to the true empirical formula. So 4 times 1 is 4 for C4. 4 times 2.25 gives us 9 for H9. So our empirical formula is C4H9. Our empirical formula mass is 57 grams per mole, 4 times 12 grams for the carbon, which would give us 48, and then 9 grams for the hydrogen, which would make it 57 grams per mole. We compare that to the molar mass. Since they are not equal, this means that the molecular formula is not the same as the empirical formula, and we just have the one last step to do. Well, our last step in solving for the molecular formula was to find the mass ratio of the molar mass to the empirical formula mass. So 114 grams per mole divided by 57 grams per mole gives us 2. We then take 2 times the subscripts in the empirical formula. 2 times C4H9 gives us C8H18. Now, when you go to the gas station and look at the pump, there's going to be something called an octane rating, and C8H18 is octane. It's not the only component of gasoline, but it's a major component. Congratulations, you are at the end of this particular video podcast from Ontario High School, and I wish you well in your chemistry studies. If you have questions that cannot be resolved here, certainly check with your classmates, check with your teacher. There are many wonderful online tutorial sites on the web that you can interface with as well, and I wish you well. Thanks.